Yeah, I'm Jan. I think it's Buzydlowski.
Yes.
Yeah.
Look at
Um,
this.
Computational thinking, data analysis, the third tenor. It's a reference to the Seinfeld episode. Everybody could name the two tenors, but they don't know who the third tenor is. And so that's how I think of the data analysis.
Jose Carreras.
Yes.
In the Seinfeld episode, that's the only guy, Maestro can only remember the third tenor. He doesn't know who the other two are. But I'm Jan Buzydlowski. I'm from Holy Family University. And this came from ST and computer science teachers. They had an operational definition of computational thinking, so it's what you normally think about in terms of formulating problems that use a computer, representing data through abstractions, automating solutions through algorithmic thinking, most efficient, generalizing. But not last, but I put it last for the purposes of this slide, is that the idea of logically organizing and analyzing data. And I think that's an important concept of computational thinking as well. So what I wanted to talk about today are some of the tools that you may or may not know about. I teach at Holy Family. We have 2 degrees, one in computer information systems and the other one is business intelligence. So this is kind of a whirlwind tour through some tools for organizing, visualizing, and analyzing data. And I can just, I guess, do a raise of hands. If you've heard about this, I'll just go on to the next slides. So, who's heard of Jupyter? I mean, who hasn't? All right. Who's heard of NumPy? Who hasn't?
Same purpose.
Matplotlib?
They have something in common.
Who hasn't heard of Matplotlib? Pandas? Who hasn't heard of it?
Never.
Oh, shoot, I don't know what to do here. I was going hoping everybody heard everything so I can sit down.
No time for anything. You'll hear about what I'm teaching. No time for anything else.
So let me, I'll just go through this real quick. Jupyter is, and I'm going to go back and forth between Jupyter. In fact, I should start this now. Jupyter is a, it takes a little while to boot up, so while it's booting up, I'll be talking about it. It's a notebook for data scientists. What it allows you to do is write code, and then you can run a block of code, and you don't need to comment stuff off, so you can run the next block of code. You can add annotation. It's really nice. I was working on a problem last year, and I said, let me try to see how this works. And I was throwing pieces of code up, and I was annotating it, and it worked really well. And the best thing about it is it allows you to go back and look at your thinking and what the steps you took in order to be able to get to the solution. And that's what I liked about it the most, is that I don't usually think about leaving the trail how I got there, but it does provide you with the trail. So this is all kind of free. So in order to get this to work, let me just sort of, the other thing too is that you guys know about Anaconda? Anaconda is it's where you can download Python, but you get a whole huge package that you can download.
Oh, cool.
And a lot of things I'm going to be talking about, Jupyter, NumPy, Matplotlib, all those things, is that you have to take extra steps in order to install it when you install Python. And if you download Anaconda, and it's all free, it's all downloaded for you. And you have all these packages, whether or not you want to use them or not. So it's like, I have my students for the second half of the programming class, the business intelligence course. They take a second half in statistical visualization. I have them download that first, because then we don't have to deal with issues about loading stuff and adding libraries and that kind of stuff.
Cool.
You have to remember it's just an Anaconda, like a really big Python.
Yeah.
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 Wow, cool.
Yeah, so we just opened it up.
These are Python then, all of these libraries that you mentioned.
These are all Python libraries. Yeah. The course I teach is that the first third of the course, because it's piggybacked on, they do 15 weeks in Python, and then they spend the next 5 weeks looking at different libraries that are devoted to data science and Python. So it works, dovetails really well.
You do a high school level? Are you high school?
Holy Family University?
Yeah, I don't know. Oh, it's college.
Yeah.
Sorry, I don't. Where is Holy?
Northeast Philly.
Oh, in Philly.
I walk to work. I went to school there as a student, so I didn't get really far.
You wandered off, but then you came back.
So let's see if we can. All right, so this is kind of how you work it.
Copy paste.
So you open up a new workbook, and you go to the conda root, and then this is what shows up. And so these are the little snippets you can run your code. So you do Control V, and then you do the Shift Enter, and it'll run the code.
Oh, wow. Huh.
You know, so it's kind of like an interpreter, but you can run a block of code and interpret it, which is really kind of nice.
Nice.
So then you can sort of do the same thing again. If you wanted to rerun that, you could just click in there and just rerun that.
Oh.
And so they're kind of isolated, so it's what you would expect. So it's, you know, it allows you to run Python, and you can try stuff, and you can try some other stuff, and you can see what the output is, et cetera, et cetera. Now, one of the other things it also does, it supports LaTeX, and it also supports markup language.
Really?
So here's an example of some markup language.
Oh, nice.
I'm used to that sound. I'm a teacher. So what you need to do is you have to make this mark down. And then you run it, and what it allows you to do,
Oh, nice.
it allows you to sort of annotate your text. So you can have boldface, you can have different headers, you can have bolded lists, you can have italics. So it's not quite markup, it's marked down, but it's, so it allows you to annotate as you do stuff. And it's also kind of nice, I've seen people use this as a test. So they would indicate what the question should be, you know, solve this problem, and then would give it to the students, and the students would write their code in that,
Right.
and then they could experiment to see how it works, and then they would return it to the teacher, and it's kind of like an interactive test.
Cool.
Yeah, it is cool.
In a lot of these groups, I'm taking a course for a class, and that's exactly what they do,
Is
is
it?
go through the assignments.
Yeah.
Wow.
Yeah. In fact, the easiest way sometimes to get people over the hump is to give them a partially filled out program.
Right.
And then they have to fill in, you know, oh,
Right,
you have to
right.
fill in the missing pieces here. But that means they have to read the, you know, the other stuff, and they start picking up style that way.
Right.
Neat.
Completion problems.
Nice.
So now, like, let's see. Yesterday I was talking about double index lists in Python, and to be able to model matrices. And one of the students says, "That really sucks." He's like, "Yeah, you know, Python isn't really known for handling matrices and that kind of stuff. It's the best with lists. I mean, I love lists. It's the greatest thing ever. But once you start getting to 2 dimensions and you have to do stuff with it, it's kind of a pain in the neck." So there's another library called NumPy, which is really good for matrices. It's like written for efficient use of matrices. You can install it with pip install NumPy, or it comes with Anaconda. So
Cool.
you download Anaconda, then you can just
It's Fortran under the hood.
yeah. It actually is.
Wow.
That under the hood, which is Fortran under the hood. Yeah, so it's trying to emulate that.
That's neat.
So here's so you import it, and this is kind of the style that you do. So you import NumPy as NP, and then you say a range of 15, it's what you expect. And so it gives you the number 0 through 14, you know, sort of like the range function in Python. And then you say what the shape is, and it shows you it's 15 long, and it's one dimensional, and it's size of 15. You can reshape this stuff. You know, so you can get 2 dimensions. It's a whole lot easier to work with. It's a 3x5 or 15 pieces, so you can shape them that way. And the other nice thing about it is that it works very well with Python. So if you have a list, so you see C as a Python list, you can just convert it to a NumPy array, and then you can look at the different types. So when that student was saying, you know, working with two-dimensional arrays in Python is a pain in the neck, I said, well, there's a better library for that, and you'll have it next semester.
Cool.
All right, so let's see, you can do stuff, I won't show you this, but you can get zeros arrays, you got ones arrays, you got the identity matrix, one of the main diagonals, that kind of stuff. This is where it comes in really nice.
Huh.
I hate computers. I got all the way down, didn't I?
Oh, yeah, where did you go?
I'm finding myself as I get older, I'm hitting keystrokes that are taking me places. I have no idea how I got there.
I disable my touchpad.
Did you?
Yeah, that's,
But the touchpad is, yeah.
Yeah.
All right, so here's an example.
Disaster now.
What this will do, it'll generate numbers from 0 to 2 pi in equal spaces. You want 20 of those numbers. That'll generate a vector. And the nice thing about it is that you can work with it just as a vector. So this will take the sign of each one of those, put that in line. So this is kind of resultant.
make a nice table.
Wow.
Yeah.
You know, so it's, you know, it's when students see this, they'll go, oh, I don't have to use the loops and stuff anymore. It's like, no, there's libraries built for doing this kind of stuff, you know.
Cool.
And when you do it with loops, it's much less efficient.
Yeah, I mean, they're sort of doing it with loops too, but it's just
Oh, yeah,
faster.
but they don't have to.
So, and again, what you can do is, might as well show you this. So here's, you know, you can take a list in Python, make it an array, make your own, then you can just deal with them just like A minus B. You know, so A is a vector, B is a vector, subtract the two. Square each element, take the sign of it, multiply it by 10, and then tell me which ones are less than 35.
Wow.
You know,
Really
it's pretty cool. Yeah.
That's very
Not bad.
cool. Wow.
So the data type of those, if you look for the type of A, you would say like a numpy array?
It would be an NumPy array. Yeah.
Is there good documentation on it? Is there good documentation on it?
It's okay.
So it's like either SciPy,
.org.
SciPy.org or
Huh.
NumPy.org, there's tons of
Oh,
Done your stuff.
I heard people call it numpy.
numpy. Or numpy.
Yeah, I've only heard it NumPy, but you can go whatever you want, I guess.
Well, it's pie.
Right, right.
Pie.
So now the other cool thing is that it works just like Python, so you can slice it, so you index it with 2, and then you can slice it 2 to 5.
Right.
You can do
So it's
replacement.
just like lists.
You can iterate it. Yeah, it's just like a
Right, so
list.
it's just
You know,
like
so all the things that they
list
learned in
and
Python apply to this. So
Right.
there's like no new learning. So this is really nice
So
about
it's all just like lists
Like
and
iterable.
range and iterable.
Right.
Cool.
16.
Cool.
Everything's got high.
it. All right, and I guess we kind of. So here, what you can do is some linear algebra stuff. So you can do transposes, which are easy enough. You can multiply the 2 matrices. You can take the inverse, which is really kind of nice. You can even do eigenvalues and stuff like that. So if you want to teach higher level concepts, you can do that. It does it all for you. It's really kind of nice and it's free.
Yeah.
Right.
So are like disciplines that normally used MATLAB starting to change over to this? Or?
That I don't know.
Yeah, I know, I was in grad school at Drexel and we had I know of several labs that had been using MATLAB, and like we had free licenses for MATLAB, like site licenses, and people were switching to Python because it's, you know, it doesn't have the nice GUI that you can run MATLAB in, but it's free. It's got lots of libraries.
Yeah,
And
it is just like MATLAB.
it's they intentionally modeled it on MATLAB to get those people. But it's a better language than MATLAB. Like MATLAB is super powerful, but it's not the greatest like software engineering language in the world.
Is your name Walter?
Yeah.
Yeah.
Mankowski?
You taught me computer science.
I've seen you on television. I guess I gotta go down to Drexel. I gotta introduce myself. I don't know if he remembers me.
On television?
Yeah, they were interviewing for something. They were asking you how you got there. You were blaming the math teacher you had at the Holy Ghost. Oh, we finally get to meet. That's excellent. All right, so I won't do this because there's another example. But you can, use NumPy to read. So you can use URL lib and download it, and you can analyze it that way. Now, matplotlib sits on top of tkinter. It's a nice way to do a visualization. You can install it via pip, or it's part of Anaconda. Here's an example of it. So let's see. Control A. So I was thinking it'll give you an asterisk. And then you can do inline plots with matplotlib.
Huh.
So it works really well.
Cool. Wow.
Jupyter and matplotlib and NumPy, they work really well together.
Cool.
So here's the.
So are you using Jupyter kind of as your IDE, or do you use separate IDE?
Using it for everything.
Yeah. You mean me personally, or what I'm doing now?
For your students,
Oh,
I mean, because you can't do like setting breakpoints and things like that, or can you?
well, like this is the second half of the course.
Mm-hmm.
So we go through all this, loops, all that stuff with the first half. And then this is really, the second half of the course is like a survey of statistical programming languages. And since they already did 15 weeks, this is what they start with because they're familiar with Python.
Mhm.
So they just sort of use this as to learn the different tools that you can use to do data analysis. And the course is statistical programming and visualization, so this works really well because then you can sort of do visualization in this tool. I use this to lecture, and I show them the different components, and I show them how to do the analysis. So, and then you can save these and just upload them to Canvas, and then they're able to download them, and they can review whatever we did.
DJ,
Yeah.
do you use Python 2 or Python 3?
I just started using Python 3 because I figured it's like my job. I should be using Python 3 from what I heard. A lot of students are complaining that a lot of the stuff that's still out there is in Python 2 and it's difficult to make the switch. I don't know what the right answer
A
is.
lot of people are using 3.
Yeah, I just started using 3. I hate the parentheses around the print statement.
That got me.
But I try to use the more current one because I feel like that's my job. I'm supposed to do that. Now here's an example of you can do 3 graphs at once. And it's really easy to do. You can just say plot. You do t by t, and you're using red dashes and t by t squared. You're using blue squares and t by t cubed, and you're using g little triangles. And it's really easy to, to plot and play around with the different symbols that you can use.
Nice.
So let's keep going through here. You can do pie charts. You know about pie charts. I'm just gonna keep it.
Where did it go?
What did I hit? How do I do that?
Yeah, there we go.
There you go.
I was telling Rebecca, I was sending an email and I was typing something and I hit these two keystrokes and all of a sudden the email got sent. It's like I wasn't finished. It's like, what the hell did I hit?
Like, what's the problem?
I was like, I must be really old now. I'm hitting stuff, I'm running
No,
into
it's
stuff.
because the latest computers are so much faster than the crap we just got rid of, and so like the computer's just going like.
You probably
Everything's so fast.
double clicked on the text.
Yeah, basically double clicks, and all these things are happening.
Right. And so Matplotlib also has like a whole bunch of statistical visualization tools like histograms and box plots. And here's an example of box plots with they have notched.
Oh, there's kind of.
Yeah. So this kind of stuff you teach in that course.
Yeah.
Oh.
Right. And last but not least,
And,
Really small figures within figures.
Come on, please. Control A, Control C, Alt Tab,
yay.
A, Control V. There's a lot of code, we won't go through it, but this is the thing that.
Oh, did what?
Work.
Oh,
There it
they
is.
are. Yay!
Here it is.
Yay!
So you can do like really powerful graphics, almost like bar-like stuff. We had a speaker here, Rich Hyber, who was actually my teacher at Temple. I had him for statistics. And he was really big on statistical graphics and S, which is now R. And this really rivals that kind of level of graphics.
They have a gallery on their website, Matplotlib website. Somewhere there's a gallery of glorious, spectacular graphs.
Yeah, it's pretty cool. Yeah, they actually do have a nice, yeah. So, all right, so where are we? So then finally, we'll do pandas. This is a set of functions to work with data frames. You might have heard of data frames if you work with R. It's kind of like a matrix that with columns, etc. So you can install it with a pip or it comes with Anaconda. I think you got the point by now. Let me skip this and I'll just go right to this. Right, so, that's a style. Import pandas is PD, so you're just changing the namespace because it's easier to type. Matplotlib and style, we're using a different style. And here what you're doing is you're having three fields, day, visitors, and bounce rate. And they're just sort of Python arrays. And what we'll do is we'll stick it into a data frame. So you can see this is coming as a dictionary in Python, and we're converting it to a data frame. We'll put the data frame, we'll do the head. So actually, you have to do this in pieces, so I can do this. So we'll do Shift Enter. Takes a little while because it's got to throw the pandas library.
I'm sorry, did you say pandas stands for anything? Does that mean something?
I don't know what this stands for. Anybody else? A little furry animal?
That's not a snake?
And Python never really was named after the snake either. It's also kind of funny to me is that when I was their age, I used to watch Monty Python.
Right,
And I just loved it, and I memorized all the lines, and I know all the skits, and I never thought in my life I would ever use it. And the language Python is based on Monty Python's The Flying Circus, and now I know all the references to the books. And so what I end up doing now is in my lectures is at the last 5 minutes of class I'll say there's references in the book to cheese shops or something, and all this stuff is on YouTube, and we spend the last 5 minutes of saying this is where it came from. and you look around the room, about half of them are laughing and half of them are going.
The name comes from panel data.
Okay. Panel data.
Panel data.
Right, so that's a data frame, so you're kind of used to that from R. We'll do. So let's see, let's take this. and then it'll show you the columns, and then and you can do describe. That's actually more interesting.
Oh, wow.
So that's really powerful.
Wow.
Is it just through one command using this data frame, it'll tell you the counts of all this stuff. You know, with just one little.
Whoa.
You know? So it's really nice that you can do analysis through this package with Jupyter, and it puts all the stuff in there, and then it maintains it. So as you're going through and you're analyzing data, you might find something that's kind of interesting, and which leads you to another point, which leads you to another point, and then you have sort of a map of where you've been.
Whoa.
You know, and until you actually use it, you think it's not that important. But if you have a really complicated data set you're trying to analyze, you can see where you've been. It's like, wow, wait a minute, I saw something like that before, and you can go back and see it. Right, so, and right, so we'll end it here.
One thing I don't think you mentioned, but just to make sure that people notice that Jupyter is running in a web browser.
Oh, yeah.
So let's see if I got connection to the internet. So what I'm going to do is go to the machine learning library from the UCI, University of California, Irvine. I used to use this back when I was studying statistics at Temple. It's still up and good. It's a really nice repository for data to machine learn. So all you're doing is you're providing the URL, so, and then I'm supplying names to the names of the fields, and then I'll just say read it, and then we'll look at the first three, and we'll describe it. So drum roll.
Yay!
Yeah. So it goes out, gets the data, brings it back in. You can sort of do an analysis, and this is a description of the data. So it's looking. So that's really powerful. You know, when you can just have all the statistics based on the data set. And then
Why did I bother? See, you didn't know.
And then let's see, let's do something. Then we want to go home.
I still have my talk.
I know.
They can't go home until I get to do my talk.
So then you can just sort of just do a histogram on it. You know, it's an easy thing to do. And then this is actually kind of cool too. Is that if you want.
Send the data to Excel.
Yeah. So what it just did, it just wrote a file to Excel.
Oh.
So I was able to take that stuff down from the web, analyze it, do whatever I had to do with it, and then I saved it as a Excel spreadsheet, pulled through, and named the sheet one. And this is all free tools.
Wow.
So let's see, do I have any parting words of wisdom? There's a nice 10 minutes guide to pandas if you just want to get a quick overview of how it works. Any questions? I'm sort of rushing through this because we got jobs, we got day jobs.